Thanks everybody for coming to our Unpacking Standards workshop, our first our first webinar of this school year. We're just going to wait just a minute to have everybody come in and then we'll get started. Okay, we'll get started now. Again, thank you everybody for coming to our Unpacking Standards webinar this afternoon. We appreciate you being here. Just so you know who we have here, I'm Heather Jenkins. I'm joined by my colleague Marissa Hooper from Demonstrated Success.
Hi, everyone.
And we also have Gray Harrington here from the Department of Education.
Hi there.
And
Glad to
then
be here.
Kristen Crawford is also, she's our assessment administrator, and she's also able to answer a lot of data questions that you have, but just doesn't happen to be here this afternoon. I just want to say first and foremost, again, thank you for coming and thank you to the Department of Education. We could not put on these webinars for free without them, so we very much appreciate all the support that they give to educators and schools within our state. You are muted. We cannot hear you. If you have questions, please ask questions in the Q&A portion or the chat portion of the screen. Q&A is a little bit easier for us to manage. So if you put it there, there is a hand raising option, or there used to be. Actually, I don't know if there is a hand raising one anymore. We might have turned it off because it becomes a little bit tricky. Oh, hand is raised. It becomes tricky when you raise your hand. It's really hard for us to be able to unmute you. So because it's a webinar, we have a lot more folks here. At the end, if you still have questions, you can raise your hand. But other than that, we will have you put all your questions in the Q&A. The other thing that we just want you to know is 24 hours at least after this webinar is finished, you will get an email with a link to the PD certificate. It is usually the hottest question there is for these webinars is, am I going to get a PD certificate? Yes. You will also get the slide deck that we have here. There's a lot of links and information available in the slide deck. And we will also point you in the direction of where the webinar will be housed once it has been edited. At the end of this, we ask that you just take a few minutes to fill out the brief survey that we have to be able to give us any feedback on the webinar. We love feedback. We look at it. We make sure to talk about it with our folks at the NHED to make sure that we're doing everything we can to make these webinars as helpful as possible. For today, our targets are we are going to learn how to unpack standards and discover those essential understandings and key knowledge and concepts that are necessary along with the skills for students to be able to demonstrate mastery when it comes to our New Hampshire state standards or the Common Core. I'm also going to turn off my video here just so that you have a little bit more room on the screen. Our agenda for today, we are going to do a standards overview. It is a standards webinar, so we just want to make sure we're all talking the same language when we are looking at standards. We are going to do some unpacking of standards, and then we're going to also look at a little bit of depth of knowledge and how to align those standards and those depth of knowledge types of questions into your instruction. And then we have some additional resources and a wrap up. All right. Just so that we love to start with a little analogy. The analogy that we have here is a map. So the way that we're looking at our state standards is basically the state standards are like that destination on the map with those key landmarks and how we're getting there. Um, they help us define all the different outcomes that we have for our students. And when we're thinking of standards, we want to think about where do we want them to be at the end, and what do we want them to be learning along that sort of road to where mastery is for a particular standard or a particular skill. A lot of us have curriculum. Some of us have built our own curriculum. That is sort of that route that you're taking. Sometimes curriculum brings you on a little bit different route than another curriculum, but all of those stops along the way are getting you to the same endpoint, which is having students understand specifically what they need to know in the Common Core and New Hampshire state standards. Just to kind of also talk about that a little bit. When we talk about curriculum, when we talk about our standards, we're working on throughout all of this our instructional strategies and the way that we are teaching it. We want to make sure that students are learning and not just that we've got this map and we're bringing them to this place that they have no idea where they're going or what they're doing. So we want to make sure that they know where they're going all along the way. When it comes to the standards for the New Hampshire state standards, we are looking at the Common Core state standards for ELA, the Common Core standards for math, and then the next generation science standards for science. Starting with English language arts, just some general information about the ELA standards. The shifts in education happened a little while back, but these are some of the key shifts that we want to ensure that folks are thinking about when we're looking at ELA. First things first is regular practice with a variety of texts, right? So we want to vary the texts and we want them to make sure that students are doing any of their work grounded in evidence from those texts. So the big thing is being able to extract that evidence and understanding and explanation of text through evidence and to integrate that knowledge across different disciplines, whether it be we are looking at, specifically an ELA or a science lesson or a math lesson or things like that. We want to make sure that we're able to pull all that information in and across those disciplines. When it comes to the college and career readiness, these are the reading anchor standards. The great thing about ELA is that you have the same 10 reading standards all the way from K through 12. So you've got key ideas and details, and everything within key ideas and details is having to do with reading closely, determining central ideas, analyzing character development, and all of that. These standards, the 10 that you see here, they are consistent throughout the grade levels, but obviously as we move up through the grade level, you have a different level of understanding and a different rigor depending on the grade level. So you have your key ideas and details, you have your craft and structure, you have your integration of knowledge and ideas, and your range of reading and level of text complexity. So each one of these, we're going to be going through and showing you how to read the particular standards within each grade level. But I find it really helpful as a teacher of ELA that we know from grade level to grade level that we're dealing with the same sort of understanding of standards and the same 10 standards throughout. The next slide here is also the writing anchor standards. So again, grades K through 12, you have your text types and purposes, your production and distribution of writing, research to build and present knowledge, and range of writing. These 10 standards, again, are the same for each particular grade level. Depending on the grade level, you're looking at a little bit different level of complexity and understanding. When we're looking at the standards, if we're talking about the domains or the reporting categories, we are looking specifically at the reading standards for literature, reading standards for informational text, and you also have your writing standards. Those are called domains or reporting categories. Underneath that, what you just saw, especially on the reading and writing, is you saw that we had certain clusters like key ideas and details, We've got those for reading standards for literature. We've got those for reading standards for informational text. And then within that, you have your standards underneath it. So as you go through your ELA standards for key ideas and details, regardless of the grade level, you can see as you look across for reading standards for literature, above there you have standard one, and you can see what it looks like for third grade students compared to what standard one looks like for fourth grade students. So it's a nice progression of those same standards as you move through the grade levels. It also makes it a little bit easier to be able to go, if your students aren't quite there yet, to be able to go down a grade level and to look at what they might be able to do with a little bit possibly easier text or what have you, but also where they came from. For ELA standards, this is what we were talking about. They're neat and tidy, right? Key ideas and details are those standards 1 through 3. Craft and structure is standards 4, 5, and 6. Integration of knowledge and ideas are 7, 8, 9. And then the range of reading and level of text complexity is that 10th standard. So the only shifting in the grade level bands is that support provided or the rigor of the actual information. It also makes it a little bit easier if you're a teacher of ELA to say, I'm a fourth grade teacher and I want students to be doing specifically this in fourth grade with the text, but then giving them a possibly easier piece of literature or something easier to read where they're able to do that same level of information that's in your particular grade level standard. Um, for math, it's a little different. For math, we are looking at the mathematical standards just overall. They are internationally benchmarked. They are helping provide guidance for building the understanding. First things first, building that conceptual understanding. It does have obviously some procedural skill understanding and fluency, but they also need application of that particular skill or focus area. There are key concepts at each grade level. It makes it a little bit more challenging if you don't have students that are up on grade level. You need to know where your standards are in grade levels that come before yours and how developmentally they progress. So we want to make sure that we are looking at those developmental progressions and those learning trajectories and linking thinking across grade levels. So it's not quite as easy to say, I'm just looking at my own grade level and teaching only my own grade level. It's really helpful for you to understand where they're coming from and where they're going to. A lot of the standards and those concepts have like that 3-year period where you're introducing in one year, you're working on it the next year, and you're securing it in the year after that. So you really want to kind of know where you are in that particular progression to be able to make sure you're meeting the needs of your students. When it comes to the key math concepts at each grade level, we have here, there is we focus on basically fewer topics within each grade level, but K to 2 is your addition and subtraction. 3 to 5 is your multiplication and division of whole numbers and fractions. Grade 6, you're looking at those ratios and proportional relationships and some into the algebraic expressions and equations. 7th grade, you're really working again on those ratios and proportions. And then arithmetic of rational numbers. And then 8th grade, you're looking at linear algebra and linear functions. So those are the major topics in each grade level. When it comes to this, where we were talking on a couple slides back, we want to have rigor in math, right? We don't want to just have that surface level understanding. We want them to really understand a concept and be flexible in their thinking. So that conceptual understanding, we have it first here for a reason. It is number one priority when it comes to mathematical thinking and understanding of specific skills in mathematics. The procedural skills and fluency, we don't want to lose sight of that. We want students to be fluent with their, addition, subtraction, multiplication facts, but it is not a focus on skill and drill. It's more of that conceptual understanding. And then that fluency helps students be a little bit more efficient with their understanding. And then the application, we want to be able to say, not only do they understand this particular skill within our classroom, but they can apply it to novel and new ideas when it comes to using that knowledge to build understanding in other areas of mathematics. When we're reading the math standards, we have the same thing. We have our domains or reporting categories within a specific grade level. Then we have also then within a specific domain, we have our clusters of standards. So we're looking at the real number system right now. We have our three different clusters that we have within the real number system, and then the standards underneath it. When it comes to the progression within math. It is a little different than ELA. You can see here that you've got starting in kindergarten that counting and cardinality, and then there is this sort of split. As soon as you get to between fifth and sixth grade, you have moving on from those concepts that you have pretty much from K to 5-ish. You've got your fractions coming in grade 3. Then you're switching completely in sixth grade, and numbers and operations base 10 moves into ratios and proportional relationships. Numbers and operations and fractions moves into the number system. And so you can kind of see that progression there, and where these particular standards come into play. So for grades K to 5, numbers and operations base 10 is really big. And if they don't have that, it will be really hard for them to move into the ratios and proportional relationships. So we just wanted to show you this progression to make sure that you understand sort of where things come from and where they go. Same thing. Oh, same thing between eighth grade and high school. You have that shift again. So we just wanted to show you that. When it comes to standards in mathematics, the folks at Achieve the Core have made it somewhat helpful for us to be able to say, what are those major things at each grade level that we need to be able to focus on? So where ELA, basically it's all your standards that are really important. With math, Achieve the Core has this, it's an algebra progression, which just keep that in mind, that it's not a geometry progression or anything like that. It's an algebra progression. It's K to 8. And basically what this tells us is we're looking at 7th grade here. It's saying what our major clusters of standards are, our supporting clusters, and our additional clusters. What this helps us with is we obviously want to cover all of the standards whenever possible. But if we are going to spend a really long time teaching specific clusters or specific standards, we want to make sure they're the major standards for our particular grade level. So we have linked here and in a Padlet to be able to have you take a look at these Achieve the Core documents. Again, they're K to 8, getting us up to algebra. Just a heads up, in the future, they might be changing them slightly. I haven't heard any, official word, but just overall, the data and statistics is becoming a really prominent set of standards within our workforce and within our world. So those might be coming up and having a little bit more importance in the future as well. But for right now, this helps us figure out how to get those kids to algebra starting in high school. This is just the progressions K to 8. It's the other side of each grade level. So it helps us understand what are those major things in each grade level. And then we have those standards for mathematical practice. I feel like these get lost quite a bit, so we want to make sure that you're always thinking about how students can use these standards for mathematical practice to become deeper thinkers and better mathematicians. They are the only thing that we have K to 12 for mathematics. And these standards of mathematical practice are the things that are going to get kids really thinking about mathematics and be able to kind of understand at a deeper level. For science, we have those next generation science standards. When we talk about domains or reporting categories, those are the big sort of buckets of science. We have physical science, life science, and earth science. And within that, we have our disciplinary core ideas or our clusters. This just shows third grade. And within third grade, we have our forces and their interactions and those interdependent relationships and inheritance and variation of traits. That is, as we are moving into a specific area of science, we have those disciplinary core ideas. So this next, I'm going to have you move to the next slide. This is just an overall look at the next generation science standards by topic for each grade level. So you can see what a lot of those disciplinary core ideas are for each particular grade level. And there's a link to how you can look at them by specific topic. When it comes to the topic arrangements, this is the overall, when you look in the next generation science standards, it can be pretty overwhelming. So I just want to break up this screen just a little bit, and we'll start with the top and then I'll move down to the middle and to the bottom. So this is that forces and interactions, right? We have these specific areas, sort of these like clusters and standards within forces and their interactions. So this tells us what students need to be able to do to demonstrate understanding. And then within the middle area, you've got, again, those DCIs or those disciplinary core ideas there in the orange. And then within that, each one of these topic arrangements has those science and engineering practices and those cross-cutting concepts. So as we're looking at different areas, we're able to make sure that we're looking at all different ways for students to understand these particular concepts within science. On the bottom, it shows those different ELA and mathematical state standards or common core standards that relate to that particular topic within science. So it's showing you those sort of cross-disciplinary standards as well, so it can be super helpful for being able to teach across the disciplines. When it comes to the next generation science standards and we're looking at cross-cutting concepts, we have a source here that just kind of helps you understand all the different ways to look at those cross-cutting concepts within a specific area of science. Not to forget, those of you who are science people or technical studies people or social studies folks, you have reading standards as well within the Common Core. These are specifically the reading standards for literacy and science and technical subjects. They are the same 10 standards, but they are from your particular point of view for science and technical studies as well. So you can take a look at those. And then the next page is for the social studies. These are the writing ones for history, social studies, science, and technical subjects. Again, you have the same particular standards when it comes to writing. This just shows the first one and they're broken down like that, but you have those same standards that you're supposed to be adhering to as well for the different subject areas and how they relate to reading and writing. For standards resources, we have a link to this Padlet. I don't know if you want to open it, Marissa, or not, but it basically gives you everything that we have for standards for math, ELA, science, social studies, any sort of specialists, and all of that. It's just got a ton of information in here. Um, and you will be able to take a look at it sort of once you get this slide deck and what have you.
I just wanted to add, we did get a question asking if we're going to be talking about PE standards today, and we are not, but we did put on a Unpacking Standards workshop last year where we were able to talk about the PE standards. So this Padlet does have a little bit of that information, but if you want to, our email addresses are at the end of this slide deck. Please feel free to reach out to us and we can send you any resources we have regarding, unpacking a PE standard in those grade level outcomes.
And then the other thing also is while we're focusing on ELA, math, and science here, the way that we're going to break down and be able to, break apart standards. And Marissa's going to go into that in the next section. And you can also apply that to what you have for your physical education standards as well. So we just wanted to give an example of each one of those grade levels for unpacking a standard, but you'll see the process is the same, um, irrelevant of which area of standards you're looking at. So hopefully it will still be helpful.
So thank you for your question. And yeah, we did actually use a PE example again. So please reach out to us if you need more information and we can give that to you. So I don't see any more questions, but please continue to ask. We can either answer them privately or address them to the entire group during the webinar. So I'm going to go now into unpacking a standard. And why we want to unpack a standard, although it does require some work on our part, it helps us to determine what needs to be taught. So we have different curriculums that we might be working with, but regardless, we have our grade level standards. So we want to make sure that, we hope that any curriculum we may get, is covers every grade level standard for, the amount of time it should. But unfortunately, that does not happen. So when we unpack standards, this will help us determine, how much time we need to spend, on a specific standard and figure out exactly what we need students to learn and show what they know. It also helps us identify opportunities for scaffolds. So the more we know the standards and the full intention of the standards, which is part of the next one, we can help students, give them different access points to be able to understand or sort of move along in their thinking with the standards that we're working on. And then it also helps us plan our instruction and what's going to help students gain both the knowledge and the skills required to master the standard and be able to apply their understanding even further. Which sort of brings us to our learning outcomes. When we go through the process of unpacking a standard, we're eventually going to, write I can statements or learning objectives, whatever you might call them in your school. And this is sort of that critical piece because without communicating clear learning outcomes for both ourselves as educators, but also our students, what we risk is, having isolated learning experiences in the classroom. And if we only teach in isolation, then we are going to fail, our students to deepen their understanding over time. And we do that because students are not able or they're not given the opportunity to make meaningful connections. So when we think about learning outcomes, just that sort of critical part to which is actually step 3 in our protocol, is that again, it provides both us as educators and our students with a very clear understanding of what skills they need in order to be learned and applied. It is critical that we make this clear to students so they know where they're going and how to get there. It's sort of like that map that Heather discussed in the beginning. You know, we need to give them the map and where they're going, why they're getting there. We know that they need that why so that they can meet expectations. And it will also help guide instructional decisions because those are going to be the basis of all of our assessments. So when we think about, the assessments that we're giving to our students, whether it's formative or summative, whatever our learning outcomes are, that is the starting point. And that's going to guide every decision we make in a lesson or a unit that we're doing with students. So this is the steps to unpacking a standard. So we're going to go through this for math, ELA, and science. But the first thing we're going to do is we want to, have a standard, but we want to start isolating keywords in the standard. This is going to help us identify the critical content, skills, and the process needed for mastery. And then once we do that, that will help us look for links. This will be between the standard, the overarching cluster, and any other standards in the cluster. And this will help students make sense of how this standard is going to contribute to their full understanding. So again, this is helping us, not have those isolated learning experiences for students and help us have a full understanding. And then once we've done that, we're going to turn those components into a learning objective or I can statement. You might call them something different at your school, but you can turn it into that whenever you have unpacked your standard. So this is our protocol. And this is a link down here to the template that we have. Again, you'll have access to this link. And through this protocol, we start with a standard to unpack. And we sort of go on these two different adventures here, where one, we start with picking out the verbs. That will help us determine the skills students need for this particular standard in demonstrating mastery, which will then lead us to what we need students to be able to do. And then for the nouns and adjectives, this will help us ourselves know what students need to both understand and know in order to demonstrate mastery, which will then help us create those learning objectives or I can statements. So we're going to start with an English language arts example. And like I said, we did a workshop on this and there was a lot to it. We were able to really go through each step and do it together. But because it's a quick webinar today, we are unable to do that. So we're sort of going to bring you through every part of unpacking a standard, but it's all right here for you. And we've worked with some teachers who have, sort of loved this template that we've given. It's clear to them what they need to do. And for some, it's a little overwhelming. So once you get this information, feel free to set it up in a different way that makes sense to you. So this first standard is that we're going to give an example for is a grade 6 reading informational text. It is to cite textual evidence to support analysis of what the text says explicitly, as well as inferences drawn from the text. So this is what we need students to be able to show. So we first start by picking out those verbs. So we have cite, support, drawn, and those verbs will then lead us to what skills students need. So they're going to have to locate in the text, refer, cite, explain, analyze. And what that does is it helps us think of all the skills students need in order to be able to cite, in order to be able to support the analysis or draw inferences from the text, which will then lead us to students being able to comprehend text and explain its intended meaning. And that means referring to details both in the text, and that's where that citing comes in, but also beyond the text by inferring. So this is what students will need to be able to do. We then think about those nouns and adjectives. We have textual evidence, analysis, and inferences. And this is going to lead us to what do students need to know? They need to know citing and citations. They need to know about textual evidence and prior knowledge. And that will help them know the difference between what it means to cite and what it means to infer. And that is showing, what the text says and what they infer from combining information learned with prior knowledge and life experiences and how those are different. So they're going to need to know the difference between the two. And then lastly is our understandings. And when we think of the understandings, this is sort of that long term, what do we need students to take with them? We need students to understand how they're going to support statements. So they're going to understand that when analyzing a text, those supporting statements should include both text evidence and justified inferences. That's that long-term understanding that we need. Once we have that, we're able to write some learning targets for students. So again, working with the same standard, we've taken what students will be able to do, what they will know, and what they will understand. And we created four learning targets out of them. And I just want you to know that when unpacking a standard, there's no like right or wrong sort of answer here. You could be unpacking the standard and come up with 5 or 6 different learning targets, or you can come up with 3. It's really what is best for you and your students. And this is just a process to, again, help you sort of dig in deeper to the standards. So when we had written these ELA I can statements, it sort of starts, from that depth of knowledge one, which we'll go into later, and also building upon one another, which is I can comprehend text and explain its intended meaning. We then take it a step further where we're going to refer to details in the text and beyond the text, both by citing and inferring. Again, taking it one step further by making inferences by combining text evidence and prior knowledge, and then explaining how an inference is different than text evidence. And then again, that sort of understanding what we want students to leave with. We want them to know that when analyzing text, supporting statements can include both text evidence and justified inferences. And now we're going to go into a math example. For this, we chose a 4th grade standard. We have given the cluster as well as the standard. It's a little long, so I'm just going to summarize it that we're just multiplying whole numbers, and we want to use strategies based on place value and properties of operations. And some confusions that sometimes students have is that they might not be secure in their basic facts or procedural fluency. And the reason we are starting to list confusions is sometimes it's helpful to know their misconceptions beforehand. So it helps in that planning, right? And removing any barriers. Sometimes not understanding how the use of an area model can be a tool for multiplication. And that could also be with any of the other illustrations or explanations as well. Sometimes we see it that, instruction focuses on the traditional algorithm and that this is a 4th grade standard that is not in the standards until grade 5. This is still, part of that conceptual understanding students are building. They will eventually get to that procedural fluency with the standard algorithm, but that is not until grade 5. And also some challenges by taking a problem that might be provided verbally to them and then representing it mathematically. So this is our example of unpacking this particular standard. When we are looking at this standard and, you know, I'm, very familiar with the math standards, they can get pretty lengthy. So it's important that, we want to make sure that we're addressing the full intention of the standard. Sometimes that can be missed. And so when we are able to unpack the full standard, we're able to understand what the full intention of it is. So the verbs that we found in this particular standard, students need to be able to multiply, illustrate, use, and explain. And so we can start to think of what skills they'll need. They'll need to multiply multi-digit numbers. They're going to need to draw to support their understanding. So that's that either equations, rectangular arrays or area models. And then they'll also need to be able to use different strategies. So we can take all that and figure out that students will need to be able to multiply whole numbers. They'll need to, they can also get a little like murky, if I want to say, like they sort of overlap a little bit. Show understanding of their multi-digit multiplication with illustrations and be able to represent multiplication using different models. So those are the skills that they're going to need. When we think about the nouns and adjectives, we have whole numbers, digits, strategies, place value, properties of operations, rectangular arrays, or area models. So students will need to know what rectangular arrays are, what area models are, equations, and multiplication methods. And when we think about what they know, they need to know the steps taken in the process of multiplication. And when we say that, we're not talking about procedural steps. We're talking about, what steps they need to take to problem solve using these different strategies in order to come to an understanding. And then their full understanding, what we want them to leave with. I think the biggest thing, we can say here is that how place value impacts multiplication and understanding how to use properties of operations as strategies for multiplication. That's that long-term understanding. And these are the learning targets that we had come up with. Again, we have quite a few listed here for this particular standard. And, we have these sort of listed separately for the skills and knowledge and understanding that students need. But again, remembering that we're not just teaching in isolation. It might start that way, but we are coming together so that students can get that full understanding and putting it all together at the end. We also have a link here for the progression of skills. This is part of the Achieve the Core. This is brought to this particular standard that we're talking about. And if we look at the progressions, we can see, where students are building their understanding and building upon, what they've learned to access this standard. So we love Achieve the Core, and we can see any prerequisite skills and where the standard's leading. So we want to include this link here. And lastly, we're going to go to science. So this is an example of a grade 2 science standard. This is for Earth systems, and these are 4 standards listed here. So we're going to focus on this first one, which is using information from several sources to provide evidence that Earth events can occur quickly or slowly. And you might see that some are highlighted, a little different than maybe some of the other examples you've seen. When you're doing this, you can sort of, we've underlined, we bolded, you can highlight, pulling out any of those verbs, nouns, adjectives, in any way that works for you. So this is a link to the what Heather was explaining earlier, giving us all that information where what students who demonstrate an understanding can do. So they will have to put this all together in order to understand Earth systems. But we're just focusing on this first standard. And this is where it includes the science and engineering practices, those disciplinary core ideas and cross-cutting concepts. And then also at the bottom, those standards for ELA and math. And so when we start to look more into that document, which yes, can be overwhelming for sure, we can see that part of constructing explanations and designing solutions is that we need students to be able to make observations from several sources in order to construct an evidence-based account for natural phenomena. And then within those disciplinary core ideas, this is where we have understanding that some events happen quickly and others happen slowly over a period of time, and the earth materials and systems, that wind and water can change the shape of land. Within those cross-cutting concepts, again, the standard is showing up for how things may change slowly or rapidly. Also, developing and using technology has impacts on the natural world, and that scientists study the natural and material world. So as we can see, there's a lot that comes with, the science standards. They really all sort of mesh together and have this overlap that we need to be sure that we're taking all of that information in when we're unpacking a science standard. So if we're looking at this standard, and what's nice with the science standards too is they give that clarification statement and an assessment boundary that can be pretty helpful and give specific examples, is that we can pull out that we need students to be able to locate information on specific topic from 3 or more sources. So that's those several sources, and then use that information as evidence. We also need students to be able to make observations to explain that Earth's processes can happen quickly or slowly. And when we put on this workshop, some of the feedback that we got is that, unpacking standards is great and it's super helpful, but it's also a lot. And we know that, time is not in your favor. You don't have a lot of it. So this is Magic Schools. It's an AI tool and it can provide a starting point for breaking down a standard. The What comes with breaking down a standard yourself is knowledge you're not going to be able to get if you use AI. However, we recommend using it as that starting tool, right? And then sort of going through it and revising and giving it a very close examination. So we know that when we can use these tools, but we need to make sure that we are vetting them as well. So this is just a link to Magic Schools that if you need a starting point, this can help you. But really, when you unpack standards, you want to make sure that you are taking part in that process. That's how you are going to gain a deeper understanding of what students need. So that way you can make those shifts in your instruction. You're able to differentiate more and provide those scaffolds. I don't think I see any questions, but you, again, please continue to ask as we continue. And we're moving on to the using depth of knowledge in order to align standards to instruction. And so after, we extract the knowledge, skills, and concepts and understanding for students, this is going to help us plan for our instruction because we're able to address that full intention of the standard. And that's going to help us give students access points and help them engage in the depths of knowledge needed to have full understanding of the standard. So this is a graphic of just the 4 different levels of depth of knowledge, where we have the level 1 is our recall, level 2 is our skills and concepts, level 3 is strategic thinking, and level 4 is our extended thinking. And this can be, of course, helpful, but we are going to display some graphics that go specifically into these subject areas. We also just wanted to, you know, talk about a little bit of the misconceptions of depth of knowledge, and that's that it's not a hierarchy. So we need to ensure that students are getting those depth of knowledge level 1 and 2 questions, or the level 1 and 2 understanding, because that is going to help them explore more complex non-routine problems. That is going to help build their understanding to be able to access those depth of knowledge level 3 and 4 questions. And then also that the number of steps is not the determining factor of cognitive rigor. I know that, at least, in the math classroom, we think that multi-step problems are automatically a depth of knowledge 3 question, and that's not the case. So we need to be looking more about the process and the complexity of learning being asked versus how many steps the problem requires. So this is an example of an ELA depth of knowledge chart. This can just be helpful. It's based on the Webb's depth of knowledge about how depth of knowledge 1 is using those simple skills. Depth of knowledge 2 is that mental processing. Depth of knowledge 3 is going beyond the text. And depth of knowledge 4 is that higher order thinking. Again, they're building on one another, just like how we had written our I can statements, that we need that depth of knowledge 1 and 2 before we can move to 3 and 4. And this is an example of a task you can do with the standard that we unpacked. So by unpacking the standard that we did about citing textual evidence, we're able to provide different leveled tasks for students. So this example of recall and reproduction, we can ask students to identify explicit details or facts from the text. Moving up a level to skills and concepts, we're able to summarize and paraphrase what the text says explicitly. And then level 3, we have that strategic thinking, which is making inferences based on textual evidence and explaining reasoning. And then that level 4 is the extended thinking, where we can analyze complex texts, synthesize multiple pieces of evidence, and draw conclusions. You will have access to these slides. I know we're sort of running low on time, so you'll be able to take a look even more deeply about the example and the skills being offered as well. This is a depth of knowledge chart for mathematics. So that depth of knowledge 1, we have recalling information. We move to skills and concepts, then strategic thinking, then extended thinking. And this is a flow chart that we like to think about in mathematics. You know, a lot of times it's about getting the right answer, and there's so much that students can take from being asked a question where there is no wrong or right answer, and it's all about sort of the strategies, the investigation, the processes that they're using to problem solve. So this is that flow chart that we like to use sometimes and have students understand that there isn't always a right answer. So that can be helpful. We also have, this is an example of the standard that we unpacked about the types of questions you can ask for depth of knowledge 1, 2, or 3. So we don't have time to quiz you, but the depth of knowledge 1 is B, which is just finding the sum of this expression. Depth of knowledge 2 is A, where students need to use the digits 0 to 9 at most one time to fill in the boxes to make a true statement. And then C is that using those digits 0 to 9 at most one time to fill in the boxes to make the greatest possible total. So then taking it a step further. If we're looking at depth of knowledge 4, that would be activities that involve analyzing and synthesizing information from multiple sources, applying mathematical models to solve problems, and conducting experiments. So this is something that we have linked here. It's the depth of knowledge matrix. This is a 4th grade example. They have, or Robert Kaplinski's, he has all of the standards listed up in and different depth of knowledge example questions that you can give to students. So if you were to click on this link here, there's for 5th, 4th, 3rd, algebra 2, geometry, it goes, it expands across a wide range of grade levels. So that is there for you to use and try out with your students. And then we have science as well, where that depth of knowledge 1 is recall, moving to skills and concepts, strategic thinking, and extended thinking. And thinking about that 3-dimensional learning, right? When we looked at that standard that we unpacked, we have our practices, our core ideas, and our cross-cutting concepts, and they're all like interwoven together. So we need to think of that when we're thinking about the depth of knowledge within our science, both instruction and tasks that we're giving to students. So that first dimension, we have our practices, which is going to focus on the scientific investigation and that engineering design. And those practices will require both of the knowledge and skills specific to that task. When we think about dimension two, that's where we're linking specific domains using concepts like patterns, cause and effect in systems. And that third dimension is where we're taking those core ideas and knowing that they are central to understanding and solving complex problems. So we're weaving all three of these together to provide that scaffold for students. This is also a cognitive rigor matrix that we've linked for you. So this is a math science example, and these can get pretty interesting because what we're asking of students here, even to be able to analyze or apply, there still possibly could be a depth of knowledge level one task, depending what we're asking of students. So sometimes we think just because we're asking a student to apply something doesn't mean it's automatically a depth of knowledge level 2, 3, or 4 type question. So this is linked here to help you be able to scaffold for students. And we wanted to leave you with this. When we're thinking about analyzing our instruction, what we want to ask ourselves is, does my instruction match what a standard is really asking students to do? And so sometimes we might be teaching a standard, and maybe we're only teaching around a depth of knowledge one or two type question. And so we want to make sure that we're matching the standard and we're addressing the full intention of the standard in our instruction. When we're lesson planning, do the lessons match the cognitive demand needed, and what should a task at that level look like? When we're designing our assessments, we want to ask what tasks match the level of demand, and when is it appropriate to serve as a formative assessment? And formative assessments, that's a whole, another piece to this that's critical, and we actually have a webinar coming up on that soon. And then scaffolding and differentiation, thinking about pre-assessments and tasks, and what do we need for varied students at their different levels of readiness, and then also how can we move each student toward the necessary cognitive demand of a standard. So although depth of knowledge level one and two are, critical in our building understanding, we still want students to move forward. How can we move them um, up for their cognitive demand? All right, I don't believe I have any questions, so I'm just going to quickly wrap up here. For the Hess cognitive rigor matrices, we have all of these linked right on the slides here. So we have reading and listening, math and science, written and oral communication. We have social studies and humanities, and getting into if you're still here from physical education, we have those linked here as well for health, fine arts, world languages, and career and technical education. And then if we want to, sort of understand our standards in more depth, we have these sites for you that you can go into. Knowing our standards is critical for so many reasons. And the biggest one is, that we can be responsive to student needs and determine where they're at and how we can help them. And that's knowing our standards. So we have linked these here for you that you can take a look at as well. We're offering some other upcoming professional learning. Again, I may have said next week, but in 2 weeks, we have the how to use formative assessment data. So how we're going to help, students move along. What does formative assessment really mean and how do we use it? This is a full workshop that we have on October 22nd. And then we have some commonly misunderstood standards webinars, both for ELA and math coming up. Again, as soon as you leave this webinar, you are going to get a pop-up of a survey. We would love your feedback. We did this webinar last year and we were able to take that feedback and apply it to this webinar. So anything you may have, both positive or constructive, we would love to hear. And again, 24 hours, and then you will get that email with the um, PD certificate, the slide deck, the resources, a recording. So that will come in time. And then our email addresses are listed here. So if you have any questions, you need some more resources, or you were a specialist today and you're sort of looking for some information on your particular subject, then we are happy to help. Please reach out at any time. And
Thank you,
hope,
everybody.
thank you.